Assalamualaikum and hi everyone. This is our video presentation for PHY 150. We choose to present about electrical transportation. So here is our team members. We have NADIA AMIRAH, NUREEN MAISARAH, KHAIRUL FARAH NORLIA, NURUL SHAHIRAH, NUR HAZIRAH and NAWAL ATHIRAH.
I am thrilled to discuss a revolutionary topic reshaping our approach to mobility, which is electrical transportation. This transformation represents a paradigm shift in vehicle conception, design, and also utilization. Traditional internal combustion engines are being replaced by electric power as the primary source of propulsion. The backbone of carbon-neutral economy is expected to be electricity. It can be generated from a non-fossil energy source, contributing to sustainability by ensuring no fossil carbon is released to the atmosphere. Throughout this presentation, we will dive into the concept, advancement, and also implication of electrical transportation. It goes beyond than just being a mode of transportation. It also signifies an innovative and sustainability approach to shaping the future of our mobility. Next, we will talk about significance of electrical transportation. The first one is energy independence and security. It can reduce our dependence on limited fossil fuels by using electricity from a variety of sources, including renewable energy sources. By diversifying our energy source, it can reducing geopolitical risk and fostering a more resilient and sustainable energy future that can improve energy security. The second one is technological advancement. Advancement in charging infrastructure have made it easier for electrical vehicles owners to charge at home or at public charging stations, cancelling the need to head to the petrol station. The last but not least, it's also good for urban planning and quality of life. In our urban environment, the significance of electric transportation become evident in the realm of urban planning and quality of life. Electric vehicles contributing to creating cleaner, quieter cities with reduced noise pollution and improved air quality because electric motors generate less vibration and noise. Sustainable and livable cities can be achieved through that.
Hi, my name is NUREEN. So next is the potential benefit and challenges of electrical transportation. So the benefit of electrical transportation is first, reduce greenhouse gas emission. Electrical vehicles produce zero tailpipe emission, which can help reduce the overall carbon footprint of transportation and mitigate climate change. Second, is a higher energy efficiency. Electrical vehicles are generally more energy efficient than internal combustion engine vehicles, as they convert a larger portion of the energy from their power source into forward motion. Third, lower fuel costs. Electricity is often cheaper than gasoline or diesel, leading to potential cost saving for consumers. Fourth, technological investment, which is the development of electrical transportation, drives technological innovation, including investment in battery technology, charging infrastructure, and smart grid technologies. Next is the challenges of electrical transportation or the disadvantage of electrical transportation. First is the charging time. Charging an electric vehicle can take significantly longer than refueling a conventional vehicle with gasoline or diesel, which can be inconvenient for some users. Two is a limited range and charging infrastructure. Many electric vehicles have limited driving range compared to their gasoline counterparts, and the availability of charging infrastructure can be uneven, especially in rural areas. Next is initial cost. Electrical vehicles often have a higher upfront purchase cost compared to traditional vehicles, although this cost differential is decreasing as technology advances and economies of scale are realized. Lastly is a resource dependency on rare earth element. Electrical vehicles rely on certain rare earth elements for their batteries, creating concerns about resource scarcity and geopolitical issues related to mining.
Next is electricity and magnetism's concept behind the application. Electricity and magnetism are two of the most fundamental forces in the universe. They are responsible for a wide variety of phenomena, from the workings of our bodies to the behavior of the stars. Electricity and magnetism are also essential for modern technology, powering everything from our homes and businesses to our cars and smartphones. Electricity is a phenomenon connected to moving or stationary electric charges. Elementary particles are carriers of electric charge, which is a fundamental characteristic of matter. The electron, which is the particle involved in electricity, is known to carry a charge that is conventionally classified as negative. As a result, the motion or accumulation of a large number of electrons produces the various forms of electricity. The figure shows the electric flows whether the property of matter causes an attractive or repulsive force with other electrically charged matter. We move to the magnetism concepts. Magnetism is the force that attracts or repels magnetic materials. Magnetic materials are made up of small particles called atoms. Atoms have a nucleus which comprises protons, neutrons, and electrons, which orbit the nucleus. Electrons have a negative charge and constantly spinning. This spinning creates a magnetic field. Magnets are objects that exhibit a magnetic field, which is a region of space where magnetic forces are exerted. Magnets have two poles, a north pole and a south pole. Opposite poles attract while like poles repel. Magnetic fields are created by moving electric charges. The strength of a magnetic field is measured in Tesla. Magnetic field line always point from the north pole of a magnetic to the south pole.
Now I will talk about the exploration of electrical transportation. In this video, I will explain more details about maglev train and the concept behind the application. Firstly, maglev trains are using electromagnetic concept which is including electricity and magnetic. This technology are not required fossil fuel. Secondly, electrical transportation are referring to the principle of electromagnetic propulsion, which is based on the interaction between electric and magnetic field. Electric current is an important rule which is used to create an opposing magnetic field. When current flows through a conductor in a magnetic field, an electromagnetic force will push the conductor in a direction perpendicular to the conductor and magnetic field. Maglev train also use three concepts, which is electromagnetic suspension, electrodynamic suspension, and inductress. So here is the further explanation about the three concepts behind the technology. First of all, we have electromagnetic suspension. These concepts are used attractive force between magnets present on the train sides and underside, and on the guideway to levitate the train. In this system, the bottom of the train is surrounded by a steel guideway. With this design, electromagnets attached to the train's undercarriage are directed upwards towards the guideway, lifting the train about 1 inch above it. During journey, additional guidance magnets placed in the train's body keep it stable. Secondly, electrodynamic suspension concept. It uses magnets to repel the train from the guideway rather than attract them. Supercooled and superconducting electromagnets are used. This sort of electromagnet can conduct electricity long after the power is turned off. Cooling the coils to extremely low temperatures also aids in energy conservation. This concept will help to maintain stability even at high speed. Lastly, inductress system, a newer type of levitating system that uses permanent room temperature magnets. This system will help to produce the magnetic fields instead of powered electromagnets or cooled superconducting magnets. Only until the train begins to levitate is a power source employed on accelerate it. In the event of a power outage, the train can gradually slow down and come to a halt on its auxiliary wheels. Once the train is levitated, power is supplied to the coils within the guideway walls to form a novel system of magnetic fields that pull and push the train along the guideway. The electrical current supplied to the coils within the guideway walls is alternating to change the polarity of the magnetized coils after every half cycle. So here we can see the interaction between electricity and magnetics in this maglev train.
Next, I would like to share to you about example of real-world electric transportation. Firstly is e-bike. E-bikes are bicycles with a battery-powered axis that comes via pedaling and in some cases throttle. When you push a pedal on the pedal axis e-bike, a small motor engages and gives you a boost, so you can zip up hills and cruise over the terrain without gassing yourself. Bikes still count as exercise, especially for people who are otherwise sedentary. Even you are in excellent shape and very fit, you still can get exercise by e-biking. E-bikes give you another device to charge. Right now, you can expect your battery lasts anywhere from 35 to 100 miles before it needs a recharge. If you buzz around on turbo all day, it will run out of juice faster than if you run on low. Secondly is e-mopeds. E-mopeds have become increasingly popular in recent years, and for a good reason. One of the biggest advantages of e-mopeds is their environmental friendliness. They produce zero emission, which means that they are a clean and sustainable way to commute. Commuting on an electric moped is also a convenient option. E-mopeds can travel at a speed of up to 16 miles per hour, which is more than enough for most urban commuters. They are also easy to park, which make them ideal for navigating through traffic and busy streets. Riding an e-moped is a noiseless experience. They produce very little noise, which means that you can enjoy a peaceful ride without disturbing your neighbors and your fellow commuters. Other than that is electric traction, as known as TRIN. Since it does not produce any smoke and corrosive fumes, electric traction is more suited for underground and tube railways. It causes no damage to buildings and other apparatus due to absence of smoke and flue gases. Electric traction has higher coefficient of adhesion since they are unbalanced force produced by reciprocating masses, as in the case in steam traction. It not only reduces the weight ratio of an electric locomotive but also improves its riding quality and tears of the track rails. Lastly is electric bus. An electric bus plugs into the electricity grid to get charged and stores the electricity in batteries. It is lower operational expenditure compared to diesel buses. Electric bus cost about 35% as much to manage since they have fewer components.
The first innovation is Alif Model A. Alif Model A is a flying car and it's actually our first electric flying cars. Can you imagine a futuristic machine that effortlessly glide along the road, behaving like an ordinary car, but when faced with obstacle or traffic, especially in heavy traffic, it transforms into an eVTOL, rising and traveling above the chaos below. eVTOL is actually an electronic vertical takeoff and landing. So let us discuss about these flying cars. So the interesting part about this flying car is, the first one is street driving. Alif flying cars can be driving on a regular urban or rural road. It fits into a regular driving lane and confined to all traffic regulatory conditions. Alif flying cars fit into regular parking space and inside a regular sized garage also. The second part is flight capability. Alif flying cars can take off in the air vertically. It can fly forward above the obstacle until a desired destination is reached. The driver and the cabin are stabilized by a unique gamber rotating cabin design. Okay, the third thing, the interesting about this flying car is actually unique experience. Alif flying cars offer a unique experience to fly in any direction, forward, backward, right, left, up and down, and an angle. It offers the ability to bypass the probability area on the ground by flying over them. It offers a cinematic 118-degree plus view for safe and enjoyable flight. Many other previews express unique experience which are not offered today. And the last one is 100 electric. Alif flying cars is a clean energy vehicle. It is safe to use inside city to keep the air clean. The hydrogen option also may be offered to customers at any higher price, but with extended drive and flight range. Okay, the last innovation that I will explain to you guys will be Atlantic Level 5 semi-truck. This Atlantic is actually an electric semi-truck. This truck is designed by a Russian designer and the name is Roman Dolzenko and Dmitry Voronezhev. These two Russian designers put their imagination to test in future where semi-trucks are not only electric but also fully autonomous. The advantage of electric semi-truck in logistics, the first one is zero emission. Electric semis produce zero tailpipe emission, making them an eco-friendly alternative to traditional diesel truck. This aligns with both regulatory requirements and corporate sustainability goals. The second one is cost saving. Electric trucks have lower operating costs compared to the diesel counterpart. Reduced fuel and maintenance expense translate into substantial long-term saving. The third one is quiet operation. Electric semi operate with significantly less noise pollution, making them ideal for urban deliveries and nighttime transport. And the fourth one is enhanced performance. Electric trucks offer immediate torque and smooth acceleration, providing excellent performance for highway driving and urban delivery. Okay, fun fact about this electric semi-truck is the designer, Dolzenko and Voronezhik, imagined a future where these semi-trucks have reached level 5 automation, where vehicles are completely autonomous and will require no human intervention at all. In contrast, it is level full self-driving. When automation does reach the holy grail of level 5, the cabin with a host of safety feeders to protect the human driver inside will be unnecessary and can be shrunken inside just enough to hold the electric motors, battery and component of the autonomous driving system.
The conclusion on electric transportation seems to be overwhelmingly positive. With advantage in battery technology, electric vehicles have become more practical, offering longer range and faster charging times. This shift toward electrification is crucial in reducing greenhouse gas emissions and combating climate change. Thank you for watching.